Okay, first of all, the warm-up assignment, you can either do it or not do it. I don't particularly care. If you want them to do it, pause it here, have them put their stuff on the board and go over their answers with them. What we're talking about today is lesson 61, simplifying radical expressions. This is something that we have done before. We did this last year, so it's going to be pretty much the same thing, maybe a little more in detail. Product property of radicals. If a and b are non-negative real numbers, then radical a times radical b is radical ab, and radical ab is also equal to radical a times b. If there are radicals that are being multiplied together, okay, they're being multiplied there. If they're being multiplied together, we can put them together under one radical. And if they're, what they're saying here, instead of saying AB, this would be, for example, if this was radical 2 times radical 3, that would give us radical 2 times 3, which is radical 6. So they're saying we can do the opposite and reverse it from radical 6, factor tree it, that gives us 2 and 3, which equals radical 2 times 3. So they want us to simplify using perfect squares. All you need to do is plug these into your calculator, see what we get here. So on the first one, plug into your calculator, radical 196, hit enter. It gives us an exact answer. We get that, whoops, we get that that is equal to 14 because 14 times 14 equals that 196. Okay. On the next one, however, when we plug that into our calculator, 320, we get approximately 17.889, we'll say. And that is not an exact answer because if you just plug that into your calculator with me, you know that your calculator showed you 17.88854382, okay? So that's not what we want. What we're going to do is we're going to factor tree this. So I'm going to split this apart. So I know that 320 will split into 32 and 10. 32 will split into 4 times 8. 10 will split into 2 times 5. So these are both primes. 4 breaks into 2 times 2, prime, prime. 8 goes to 4 times 2, prime, and then 2 times 2. Okay, once we have this, we can say that radical 320 is also equal to radical, and then everything that we have listed out. So we have 1, 2, 3, 4, 5, 6 2's, and 1 5. Okay, so some prior knowledge that you hopefully have is that radical 2 times radical 2 will give me radical 4. And okay, I apologize for that. Mr. Hostetter came in while I was in the middle of recording. So what we've done here is we've taken the prime factorization of 320, and we can show that prime factorization inside of one radical. And I'm showing you here that radical 2 times radical, there we go. Radical 2 times radical 2 gets me radical 4, which we know radical 4 is equal to 2. So anytime that I have these doubles inside my radical, I can pull them out as one of those things. So this radical 2 times radical 2 is going to give me just 2. This radical 2 times radical 2 will give me just 2. And this radical 2 times radical 2 will give me just 2. So what I'm left with is 5 inside of that radical. So 2 times 2 times 2 will give me 8. Radical 5. This is my final answer. It wants us to simplify radical 90 using the prime factorization. The last one I know told us to do it using perfect squares, but I feel like it's more of a hassle than it's worth, so we didn't do that. So we're going to do the exact same process that we just did with 320. So we're going to split 90 into what will go into it evenly. So we have 9 and 10. 9 splits into 3 and 3, which are prime. 10 splits into 2 and 5. So instead of saying radical 90, I can say that radical 90 is equal to radical 2 times 3 times 3 times 5. Now, just like before, we're going to do the exact same thing here. Any doubles that I have, I can pull out as one of them. So I only have double 3's. That means my 3 is coming outside of the radical, and I'm left with radical 2 times radical 5, which is going to give me 3 radical 10, final answer. It wants us to simplify using powers of 10. All right, so whenever we do this, we're going to write them with exponents instead. So you should know that anytime that we have trailing zeros like this, we can write that as each zero is a power. So I have 1, 2, 3, 4, 5, and 6. So I could write this as radical 10 to the 6th power. Okay, you can do several things here. You can just punch this into your calculator, or you can split this up and know that this would be the same as saying radical 10 to the third times 10 to the third, because we know when we're multiplying by the same base, we add the exponents, so it gets us that 6. And because I have 10 to the third times 10 to the third, I can take those out, which gives me just 10 to the third, which is the same as 1,000. I understand that you have a calculator, and you know that my biggest thing on little mathematical things like this is that you get the right answer. So if you're not sure, plug it in and get it right. Okay, on the next one, same situation. We have 1, 2, 3, 4, 5 zeros. So that's going to give us radical 10 to the 5th. And I can split this up and say, how can I split up 5? I could turn it into 2, 2, and 1 because I'm adding them. So I have 10 to the 2nd times 10 to the 2nd times 10 to the 1st. Okay, I have a double 10 to the 2nd, so that means I can take it outside of my radical. And then I have radical 10, whoops, not equals, sorry, erase that. And I have a radical 10 left inside. So 10 to the 2nd is 100, so 100 radical 10 is my final answer. Okay, on these, it's going to work the exact same way with the variables as it does with the numbers. Anytime I have a double, I can take it out. So I have 96. I'm going to break it up. So I know that 3 will go into that 32 times. 3 is a prime. 32 splits into 4 and 8. 4 splits into 2 times 2. 8 will split into 4. Whoops, gosh darn it, sorry. We'll split into 4 times 2. And 4 splits into 2 times 2. So I could rewrite this and say, instead of radical 96, g to the 3rd, f to the 6th, I have radical 2 times itself 5 times 3 times g times g times g times f times f times f times f times f. That's 5 times f. So any doubles I have, I can pull outside of that radical. So I have double 2, double 2, double g, double f, double f, double f, and inside, all that I have left is 2, 3, and this g. So I have 2 times 3 times g, which is going to give me 2 times 2 is 4, g, f to the 3rd power, because there are 3 here, and then on the inside I multiply what's left, so, oh, gosh darn, I keep putting an equal sign, excuse me please. Okay, so what's left on the inside, I multiply together, so 2 times 3 is 6, and there's a g left. So my final answer is 4g f to the 3rd radical 6g. Okay, if I could get you to, Mr. Woods, please pause the video and have them try B on their own paper. Give them about 1 to 2 minutes to get it done, and then play what I have so that they can check their answer. Okay? All right, for the next one, we have radical 54, p to the 7th, q to the 3rd. We're going to start the same way as before, and we're going to break down that 54 using prime factorization. So we know that 9 and 6 will go in evenly. 9 is 3 times 3, circle our primes. 6 is 2 times 3, circle our primes. So I have left 2 times 3 times 3 times 3. I have p times itself 7 times, so 2, 3, 4, 5, 6, 7, and then q 3 times. I can now pull out any doubles. So I have double 3s, pull it out. 1, 2, 3 double p's, and 1 double q. So then I'm left on the inside with 2 times 3 p q. Oops, q. So my final answer will be 3 p to the 3rd q radical 6 p q. Final answer. Okay, finally, example 5 is Paolo has a square bedroom. The area measures 72 square meters. Find the length of one side of Paolo's bedroom. So this is the same thing that we were doing whenever they were giving us a perfect square. I hope that we remember doing this. We know that his bedroom is a square, so I draw myself a nice square. Now I know that the area of that square is equal to 72 square meters. How do I find the area of a square? I hope that we remember that the area of a square equals side times side, which is going to be the same as area of a square equals side squared. Okay, because all of the sides of a square are the same length. That's what makes it a square. So now what I know is that the area is 72 square meters. So I'm going to plug that in for A, for the area. So I have 72 equals s squared. The opposite of squaring is square rooting. What I do to one side, I must do to the other. So square and square root cancel, leave me with s equals radical 72. Do you think this is how they want you to leave your answer? No. Okay, so we're going to split 72 up. 72 will split into 8 and 9, 4 and 2, 2 and 2. 9 splits into 3 and 3. So inside of that radical, I have 2 times 2 times 2 times 3 times 3 is equal to one side length. So I can pull out a double 2 and a double 3. So 2 times 3, left with radical 2 on the inside, equals my side length. 2 times 3 is 6, radical 2 equals s, and I need to make sure that I label that meters. Final answer. So if you had any problems with any of that, or you needed it paused to go back and check the answers, whatever it is that you need to do, make sure that you're totally understanding before you get started on your homework. Today's assignment is not this. It is lesson 61, and we will do A through G, and we will do 1 through 7. And finally, we'll do 18 through 30 even. This will be due tomorrow whenever I am back in the room. And if you have any questions, I'm sure that Mr. Woods will be more than capable of helping you. Mr. Woods, will you please write the assignment on the assignment board for them so that they see it up there as well? Thank you very much. Be good.